I'm going to be building a taser using a boost converter. I just wanted to document the process because I love doing stuff like that. I'm no computer engineer, I'm no electrical engineer. I just do this for fun because I really love it and I love learning it. So this is basically my first big project involving soldering. So these are just the pieces I have laid out. Board is just going to be used in the first initial stages when I'm going to be prototyping, just building and planning this out. Yeah, so we have our breadboard, we have our general board, prototype board, whatever it's, I still don't know what it's called. Then we have a Arduino clone, because I didn't want to fry this thing just in case. Power cable that I'll be using in the initial stages to power it on here. But eventually I want to transition to using a 9-volt battery because making a taser, I want it to be a handheld, right? So I don't want to be carrying out a breadboard and then have it connected to my keyboard or a wall or something. So we're going to be using a 9-volt. This is going to be the final thing. So it's going to have a 9-volt for power. It's going to have an on-off switch using this toggle switch right here. It's going to be controlled using this Arduino Nano clone. I know very well you could get away without using this, but I just want to do some programming, you know, practice my programming because that's what mainly what I do. Trying to go back to school to get my computer science degree, and I love coding and building stuff like this, and just combining these two, it's just awesome. And then we have a PNP transistor, which I'm going to use to control this boost converter right here. Now this is the cool part. I love this thing right here, man. I did a little experimentation with it yesterday, and man, this thing does not disappoint. And I want to activate it using either this button. I'm not sure which button to use because see, I like this blue button because it's bigger. I'm probably gonna go with this blue button. The only thing I just don't like is because it sways a little. I don't know if you guys can see that, it sways a little. I don't know, it's just very minor thing. So I'm probably gonna go with that one and toss that one. This is just really small. Yeah, so this is basically what I'm gonna be using in the first stages when I'm building the circuit on the breadboard. Yeah, we're not gonna need these for now, so I'm just gonna set those aside. This is essentially what I'll be building on here. I'm gonna have the Arduino Nano clone here, and I'm gonna set up the circuit without this toggle switch initially. I just want to get it working, the boost converter working with the button, the transistor. I just want to set that up first, and then I will be implementing this toggle switch. And if I have time today, either today or tomorrow, eventually I'm gonna take the end of this off, and then I'm going to have these two cables to be able to power my handheld taser. Yeah, so here's the negative, the positive, and then here's the two output, which is basically going to be creating the arc. What I had to do, or what I did, just to be able to use it with this breadboard, I just cut one of the jumper wires, and then I connected the positive leads to the jumper wires, so I have these pins on it and I can just plug it into the breadboard and it works phenomenally. Yeah, so I won't be using that, but when I'm connecting it or soldering it to here, I'm gonna be obviously taking off these jumper wires right here. Yeah, so right now I'm just going to build the first initial base circuit with just the button, the transistor, the Arduino clone. So this is what the setup is looking like right now. If you look right there, we have the two output wires. Yeah, there's the boost converter, and then over here's the good stuff. There's our Arduino Nano clone. Here's our 5-volt power to that rail, and then our base, the base of our transistor, which is basically what is going to be controlled with our C++ code, is connected to D3. Our button is connected to D2. The button is basically going to be telling us when to open this transistor, let the current flow. Then we have 5 volts feeding right into this emitter of the transistor. The collector is connected to the positive lead of this boost converter, and the negative lead is grounded, and the other side of the button is grounded. Yeah, we're just gonna write some code really quick in the Arduino IDE, and here we're just setting it up, setting the button pin as input with the internal pull-up. Transistor pin is set as output. Then we're just ensuring that the transistor is off, and then right here we're getting the current button state. We're reading the button state, and basically if current button state is equal to low, that means the button is pressed. So then we're going to turn on the transistor, else if it's high, it's going to be off. So yeah, I'm about to plug this in, and then we're gonna upload it, and then we're gonna see if this works. So as you can see right there, we got it plugged in, we got it ready. We're just gonna upload this real quick. Boom, upload, getting it uploaded. So as you can see, so I moved them a little closer together. It's about 10 millimeters. As you can see, so just so you guys can see me pressing the button. Right, here's the button. There's the arc. Oh yeah, so I'm gonna have to borrow something from my dad so that I could strip these cables. We're gonna be hooking up this 9-volt next. I'm gonna have to cut the end of this off and then strip the wires so that I could connect it to this breadboard instead of the power via this. We're gonna be powering it via this 9-volt. As soon as we get that working, then we could start implementing the switch. We got this thing disconnected right now, so this is what I'm talking about right here. I stripped the end of the wires right here. This positive lead of the 9-volt is supposed to go into this VIN pin right here. VIN right there, so I'm gonna be connecting it to the VIN. And then negative just goes to any of the ground, so I'm probably just gonna put it into that ground there. So I connected these leads to the VIN pin and the ground, and nothing was happening, no lights were lighting up. So I took out my multimeter and then I tested it, and it was sitting around 5 volts. It's reading around 5 volts, and apparently it's not working because the VIN pin requires 7 to 12 volts. So right here, apparently we do need 7 to 12 volts. Here, just from the Arduino documentation, just to make sure that's correct, nano 7 to 12 voltage. So here's the fresh 9-volt battery. Yeah, it's fresh 9 volts right there. So that was definitely the issue because now I have it hooked up. As you can see right there, we have a power light. So now that I know that works, I'm going to be implementing the switch. So the positive terminal of this battery is connected to the common pin on this switch, and then the other pin is connected to the VIN. So when this switches to the left, there's no power. As you can see, there's no power light right there, but when I slide this over to the right, we have power. And if I hold this button, this should arc. So here's what I got. This is basically what it's going to look like. I'm going to have the battery on the right. I'm going to have the breadboard right here, the boost converter module behind that. My button's going to be towards the top. My switch is going to be right here, my transistor, and then my Arduino is going to be here. So right now I'm just getting ready to solder. That's the switch under right there. I also have the button on there, and then I'm going to be adding the transistor. All right, so I'm not going to lie. I did get kind of carried away. Yeah, so this is the aftermath, but this is what the board is looking. It took quite some time. It was a lot more time consuming than I thought, and I know it's not beautiful. These solders, man. I've never soldered before, so just look at that. Like, actually atrocious, like exposed wire, 2-sided tape. It's all glued together, but I mean, it works. We got the switch right there, we got the button up there, the transistor, 9-volt, all wired in. Let's take our anger out on this duck. Final product right here. Turn the switch on. Cheers.